you're given 1. So here we're given a graph. Let's represent it using the other forms first, and then we'll answer the question about domain and range. So let's start by using ordered pairs. I'll abbreviate that to OP for the 5 blue points that we have on the graph here. This point is located at -2, -3, representing it as an ordered pair. This point is located at -1, 1. This point is located at 1, 3. This point is at 2, -2. And this point is at 3, 1. It's very easy then to pull these numbers into a table. We just create a table with x on the left, y on the right, and pull the numbers directly in. So -2 goes with -3, -1 with 1, 1 with 3, 2 with -2, and 3 with 1. A mapping diagram, which is the most interesting, so we'll call that MD for short. We want the word input actually on our diagram and the word output. Draw a little box to put our input values in and a little box to put our output values in with no repeats. So anything that shows up twice, we're not going to write twice. Now our input values are all 5 different numbers, so I have to write those all here. I'm looking at the X column from the table, filling those numbers in as my input. For my output, you can see that I have a +1 on that list twice, so I don't need to show it twice. I'll only list it one time. And it's okay if one box has more numbers in it than the other box, because now we're going to use arrows to show the connections. So -2 corresponds with the -3. -1 connects to +1. 1 connects to 3. 2 connects to -2. And then the 3 has to connect back up to the 1. So the 1 has a couple of different arrows coming into it. And now it's very easy to state the domain and range. Just write the word domain, or you can abbreviate it to D, and list the numbers that are in our domain. I'm looking at the X values on my table, -2, -1, 1, 2, and 3. And for the range, again, I don't need to repeat on this list, because if it shows up once on the list of the range, then I know it's part of the range. So I'll just include -3, 1, 3, and -2, and that answers the question. A function is a specific type of relation for which each input value has exactly one output value. So no more than one value can go with each input. So you're going to be asked to identify whether what you're looking at is a function or not a function. They're both relations, that's for sure, because they are pairings of inputs with outputs. But specifically, we're looking to see if each input has only one output that goes with it. So when you look at the first example, I see a red flag right here. I see the number 1 being used twice as an input value, going to 2 different output values. And that tells me that this is not a function. So when you answer the question, not only should you say that it's not a function, but you should explain why in a quick sentence. You should say, because the input 1, I'm going to be specific here, the input 1 has 2 different outputs. And that's what makes this not a function. It goes to 2 different numbers. Whereas the second example over here, I have 4 different input values, -3, -1, 2, and 4. And even though the 2 and the 4 both connect to the same output, that's not what we're testing here. We're testing to make sure that each input goes to only one output. And that's true, because none of those input values are repeated. So for this one, we can say it is a function, and if you're asked to explain why, it's because, and you can get this directly from the sentence at the top of this slide. Each input has exactly one output. Exactly there is being used like the word only. It has only one output, not more than that. You might be given a graph and asked to say if it's a function or not a function. So even though you can't see the points, the ordered pairs here, this is just a series of points that got all connected to create this kind of C-looking curve. And to determine if it's a function or not, I'm going to draw this vertical line here and show you something interesting. If you draw a vertical line through what's on the graph, you can see that at this point, which might be something like, I'm going to make up a number here, that might be something like the point -2, 1. It's about right. And then this point right here on the same vertical line as it would be located at something like -2, -1. And you can see that you've got the same input value there, being connected to two different output values, two of the same x values being paired with different y values. So this we know is not a function. What we just did there is often called the vertical line test. It's a test to see whether something is a function when you're looking at the graph or not. If it goes through more than one place, that means you're looking at something that's not a function. So for this one, we would have to say, not a function. And if you wanted to give a reason, you could say because it does not pass the vertical line test. I won't write that again, I'll just put an arrow. It does not pass the vertical line test.